Okay, here's a good stoichiometry question. It also looks at ions too, because the question says how many nitrate ions are left in the solution after the thing reacts, which is an interesting question because I have nitrate here and I have nitrate here. So it's in the reactants and in the product side. Um, but I have more information than I need about each of these, so it's not just a straight what's the concentration here, but it's a little bit more involved. What's the concentration of the nitrate left in solution after the reaction finishes? Okay, so let's first figure out moles for each one. So I've got 15 mils and it's 0.3 molar. So moles of this is equal to C times V. The concentration is 0.30 moles per liter, and the volume was 15 milliliters. So times 0.015 liters. So the moles of that one, 0.3 times 0.015. Okay, 0.0045 moles, and that's of the sodium phosphate. Okay, now let's figure out moles of the lead nitrate. Again, C times V, concentration, it looks like it's 0.29 moles per liter, times the volume, looks like it's 20, so 0.020 moles, or liters. So 0.29 times 0.02, 0.0058 moles, and that's of the lead nitrate. Lead 2 nitrate. Okay, so I know how many moles I have. Now I have to figure out which one is the limiting reagent. Okay, so to figure out the limiting reagent, I'm going to take one of them. I always use the first one, 0.0045. So this is how much I have of the sodium phosphate, and I'm going to multiply it by 3 over 2. So times 3 over 2, and so that says 0.045 times 3 divide 2. It says 0.00675 moles of the lead nitrate. So I have this many moles, and I would need this many moles of the lead nitrate. But I have less than that. Right? So this is how much I need, and this is how much I have of the lead 2 nitrate. So I don't have enough of this stuff. This one's in excess. So this is my limiting reactant, this one. Okay, so that's my limiting reactant. So now let's do the river thing. So I have, this one's going from a liquid to a liquid. Well, liquid to moles to a liquid. Okay, I've already found out how many moles I have, so that's step 1. That's this step. So step 2 is to figure out how many of these lead nitrate, or not lead, sodium nitrate I'm going to have. So I'm going to take my moles of lead 2 nitrate, and I'm going to convert it to moles of sodium nitrate. Okay, I'm just checking your balancing. Yeah, the balancing all looks good. Okay, so to do that, I take this number here. So 0.0058 moles of lead 2 nitrate times it by what I want is 6. So 6 moles of sodium nitrate for every 3 moles of lead 2 nitrate. Okay, so let's see what that comes out to. Okay, so 0.0058 times 6 divide 3 equals. So the moles of sodium nitrate that I have are 0.0116 moles. Okay, now one of the problems I have with this question is that I don't know what the volume for this is. They didn't say what the volume is. But I guess if it's reacting, this volume here will be the combined volume of both of those substances that I started with. So the volume would be 15 and 20 is 35 milliliters. 0 liters. Okay, so the third step is to take the moles of sodium nitrate and convert it to concentration of sodium nitrate. Okay, so C equals N over V. The number of moles, 0.0116 moles, and the volume is 35 milliliters, or 0.035 liters. Okay, let me divide that, 0.035 liters. So this comes out to 0.331428 moles, per liter. Now, one thing you probably should do at the end of the question, and I think this is the correct answer, round it to the right sig figs. It'd be 0.331 molar. But you should also write a net or an ionic or dissociation equation. So sodium nitrate, it would dissociate into sodium ions plus nitrate ions. The key thing here is that one of these produces one of those and one of those. The concentration I got here is this one here, 0.331 molar. But if it's a 1-to-1-to-1 relationship, then the concentration of these other things will be the same. Okay, I hope that helps you with that question. That's a nasty one. I won't give you one like that on the test. I will give you a limiting reagent question. You get 2 of those, but this one's a bit more difficult. Anyway, good question.